Okay, welcome to Chapter 4, the first lesson, 4.1, Writing Equations in Slope-Intercept Form. So what we're going to learn today is to write the equations in slope-intercept form, then to use the equations to solve some real-life problems. So first example, if you're given the slope and the y-intercept, you should be able to write it in the form y is equal to mx plus b. Remember that slope is substituted for m, and the y-intercept is substituted in for b. So in this first example, with a slope of -3 and a y-intercept of 1/2, we get y is equal to -3x plus 1/2. For b, with a slope of 0, so this is going to be a horizontal line. The y-intercept is -2. So when you substitute in a 0 for x, anything times 0 is 0. So basically, we don't see the x in our final simplified equation. So we get y is equal to -2. So in your student journal, you'll find these on page 99. Let's give a couple of these a try. So we have the slope equal to 0 and a y-intercept equal to 9. Remember, we're going to be putting it in y equals mx plus b form. So we'll substitute those in. So y is equal to 0 times x plus 9, and anything times 0 is 0, so we can simplify to y is equal to 9. Okay. Number 2, we'll have m is equal to -1 and b is equal to 0. So substituting it into the linear equation form, we have -1x and then plus 0, which means we could just write it as y is equal to -1x. Okay. The last one here for us, we have a slope equal to 2. And the y-intercept b is equal to -3. Therefore, you could put that into the form and get y is equal to 2x. And instead of plus a -3, we'll go ahead and write that as -3. Okay. Hmm. All right. Next example, to use the graph to write the equation. We have 2 points, so we can find the slope, okay? And it's the change in y. Remember, slope is change in y over change in x. So the other thing you can do too is kind of make a slope triangle. Take from this point, we'd be going down in the down direction, and that would be 1, 2, 3, 4, 5, 6. So the change in y is -6. From here back to the other point is a change in x of 1, 2, 3, 4, -4. So if we wrote this, we would have -6 over -4, which would become a +6 over 4, which then simplifies to the 3 over 2. Okay, so you could either, calculate the slope just by calculating the slope between the 2 points given, or you could draw your slope triangle. Just remember that direction matters, okay, and that it's always going to be the change in the y-coordinate as your numerator, the change in the x-coordinate as your denominator. Looking at the next one, b. So we're going down 1, 2, 3. So we'll go down 3. And then we're going to go to the right, 1, 2, 3, 4, which is a +4. So we have a 3 over a positive 4, which gives us the negative 3/4. So also, as a final note, when you're looking at A, we know that this is the line of a positive slope. And so that's how either the double negatives simplify to positive, or if you calculated it this way and got out, you get positive, positive. In the end, your simplified version is a positive value. For B, since this is a negative slope, our slope should calculate to be a negative. Um, and then you're going to obviously then use this information from here. You calculated the slope. You also need to evaluate or know where it's crossing the y-axis, right? On A, it's crossing there at a negative 3. So this is your slope-intercept form of the equation. And for B, it's crossing at a positive 2. So here is our slope-intercept form of the equation. So we're still gathering the same amount of data that we had in the previous example. So we'll be doing numbers 7, 8, and 9. So we need to identify, if you want to identify your slope, and then your y-intercept, okay? So if you want to use the slope formula, you can calculate it, or you can use the idea that you could draw it, right? Going down, so we have 1, 2, 3, 4. So we're negative 4. And to the right, a positive 1. So the change in y is negative 4. The change in x is a positive 1. It simplifies to negative 4. This point, whenever x is equal to 0, the y coordinate is your y-intercept, and it's negative 1. So we should get for number 7, y. Remember, we're going to substitute it into this equation. Y is equal to, we have negative 4x, and then plus a negative 1 or minus 1. Okay, moving right along, identify the slope, and you can calculate it. Maybe we'll calculate this one. So we need to have the change in the y coordinates. So we'll call this, this will be like 0.2, this is 0.1. So we can take 4 minus 0, change in y, over 2 minus 0. So we'll get 4 over 2, which simplifies to, simplifies to 2. So slope is equal to 2. Again, the y-intercept is the point where it's crossing the y-axis, and it's the y-coordinate of that point, which is 0. So in slope-intercept form, we could substitute in those values. And again, we do not need to write the 0, so y is equal to 2x. Okay. Finally, so we're going down 2 and back 2. So our slope with a negative 2 divided by negative 2 is a positive 1, simplification. And then the y-intercept is at the positive 1, because we can see that point right there. So in slope-intercept form, substitute in those values. Y is equal to 1. Remember, we do not need to write a coefficient of 1, but it does not make the x disappear. Only a coefficient of 0 or a slope of 0 would make the x disappear. And then x plus 1. So y is equal to x plus 1. Okay, so if you have any questions on any of these, make sure to write those down so that you can be sure to ask them and get the help that you need as you're building these skills. Okay, so using 2 points to write an equation. Now, right now, one of the points will be the y-intercept, all right? So we will calculate the slope, which we can use the slope formula, y2 minus y1 over x2 minus x1, and then identify which one is the y-intercept. So when you take negative 1 minus 5 and then 0 minus the negative 3, right, that simplifies to a negative 6 divided by 3, so we get a slope of negative 2. The line crosses the y-axis right here at this point. That's our y-intercept, and it's negative 1. So y equals negative 2x minus 1. So this is our y-intercept, and then we calculate our slope, negative 5 minus the negative 5, right? So this y minus this y, and then 8 minus 0, this x minus this x. In this case, we're going to get, so we have a negative 5, and the reason this is equal to 0 divided by 8, and then it's equal to 0, so you have y is equal to, right, our y-intercept is negative 5, but 0 times x, it kind of makes that x disappear. So we have this horizontal line. Okay. So we will try some numbers 13 through 15 in your student journal. So go ahead and calculate the slope. And it really doesn't matter which point you start with. It just matters that you do it in the same way for your change in x and the same way for the change in y. So I always just go to the second one and subtract this way. So I would do my slope is equal to 4 minus the negative 4. And that's going to be over 8 minus 0. Now when you have a double negative, you're adding. So we'll get 8 over 8 equals 1. This is the y-intercept because the x-coordinate. So the y-intercept is equal to negative 4. So in my slope-intercept form of the equation, I can write it as x minus 4. Okay. You want to pause the video and try number 14. And I'll just kind of keep working. That way you can kind of give it a try and make sure that you're on the right track. So solving for the slope, we have negative 7 minus 1 all over 0 minus 2. So negative 8 divided by negative 2, our slope is going to simplify to a positive 4. Negative divided by negative is positive. B is equal to negative 7 as indicated by the y-coordinate when the x is 0. So in our slope equation, we substitute in these values. So y is equal to 4x, and then instead of a plus negative 7, we can just write minus 7. Okay, same thing for number 15. Go ahead and pause the video and give this a try. Start by calculating slope. Having some technical difficulties here. All right. So we have 3 minus 2 is our change in y, and 4 minus 0. So we have a slope of a positive 1/4. The y-intercept is a positive 2 right there. So we can write the equation 1/4 of x plus 2. Okay. Now we're going to get into some function notation. So if we're going to write a linear function, right, we just want to use the function notation instead of the y. So we're given these values. We have f of 0 equals 10. Remember that we're talking about f of x, a function of x, and the x is the independent. So this is our x coordinate, and the result of which the whole thing is representative of what our y is equal to. So we have this ordered pair, 0, 10, and we have f of 6 is equal to 34 is this ordered pair, 6 and 34. So here's your two ordered pairs. Now it looks just like the previous example. Calculate your slope, identify the y-intercept based on the value when x is equal to 0. That's where it's crossing the y-axis. So this time, go ahead and substitute it in slope-intercept form, and then replace your y with your function notation, just f of x. So f of x is equal to this function. So we'll practice this a little bit. 19, 20, and 21. These are on page 100. So always start by listing what the ordered pair is. So this is 0, comma, -5, right? You have your input and you have your output. Input, output. All right, 4, -3. So then you can write the slope would be -3 minus the -5 all over 4 minus 0, making sure that you're understanding that you're adding here. So you'll have 2 over 4, which simplifies to 1/2, a slope of 1/2 and a y-intercept of -5. So mx plus b, we would have y is equal to 1/2 x minus 5. So we write f of x is equal to 1/2 x minus 5. So that's all we're doing is substituting in the function notation for the y. Okay, so again, start by the ordered pair. You have an x value of -5 with a y value of 5. You have an x value of 0 and a y value of 10. Calculate your slope. So 5 over 5 is equal to 1. Your y-intercept is the y value when x is equal to 0. Put it into slope-intercept form. Substitute in for m and b. And then change your notation to f of x. Okay? Start with your ordered pair. All right, if you want to pause the video and go ahead and calculate this to make sure you can do it, and then finish up by checking your work. So -4 minus 5 all over 9 minus 0. -9 over 9 is equal to a -1. So our y-intercept is equal to 5. This would be equal to a negative x plus 5. Now we write the function notation. Negative x plus 5. Okay. How'd you do with those? So if you have any questions about this, be sure to ask. All right. So when we're solving a real life problem, we want to make a linear model, and we'll try to do this in such a way. So this linear model is a linear function that models a real life situation. When a quantity y changes at a constant rate with respect to the quantity x, we can put it into slope-intercept form. We know that the value of m is the constant rate of change, also known as the unit rate, and the value of b is the initial or starting value of y. So we have an electrician who's charging an initial fee of $50, and the electrician charges $190 after he completes 4 hours of work. So we know that if we're going to put this into like slope-intercept form, right? We have mx plus b. All right. So we have our slope, and we know that x is representing the hours. And then our starting point is 50, right? Because he has an initial fee of 50. So there's always some flat rate or initial fee. So what we need to find out is what is our slope. We are given information that tells us that the output is 190 after the input is equal to 4. So we would have 190 is equal to our rate of change times our 4 hours plus the original $50 initial fee. Okay, so we can kind of set up this skeleton equation to solve for the slope in this case, and it would also represent our hourly rate. So if we subtract the $50 from both sides, we'll have 140 is equal to our slope times 4, right? So we can divide both sides by 4. And our slope in this case is going to be equal to 35. So we could write the linear model. So the cost, right, or the that he charges is 35h plus 50. This would be our function, right? Or we could say C of h, right? Just another way to write it. So how much does he charge per hour? Here is our unit rate right there. Our hourly rate would be $35 per hour. Okay, so that concludes the notes on lesson 4.1. Be sure to record any questions that you may have and be ready to practice these skills in class.